All right, so here we are, CT2, correspondence and transformations. We talked about in class what a correspondence is and how it's different than a congruence. So that's what this first part is just coming back to. We'll look at congruence. If two figures are congruent, then there's a sequence of, right, two blanks. We've got rigid motions. Okay, you got to know that. Sequence of rigid motions that maps the first figure onto the second figure. So this is just an example of congruence and how we can show that all these corresponding parts are congruent. Right? We can say that triangle ABC is congruent to, and this has to be in the right order. A corresponds to D, so we have to start with D. We want AB, so we have to go DE, DEF. Right? So all these corresponding parts are also congruent, basically based on the definition of congruence. So A is congruent to D, B is congruent to E, and C is congruent to F. Okay, and then all these corresponding sides are also congruent. AC is congruent to DF. And remember, we can look at the image, at the picture, or we can also look at the statement. AC, DF, BC, and EF, and AB and DE. Okay, I know this is just review. The idea is just to connect it to this idea of correspondence. Okay, so there's a difference. If there's a correspondence between two figures, then there's simply some function that pairs the parts of one figure to the parts of the other with no requirements concerning same measure or existence of rigid motion. So the idea is there could be a connection between the two shapes, but it doesn't mean you got there through a series of rigid motions. They don't have to be congruent. So this is true with similar figures. Let's say this triangle has been shrunk down to that one. So C and F there's a correspondence there. They're corresponding, but they're not congruent. And so, like in this case, we can say triangle ABC is similar to triangle DEF. Now, when we just talk about the correspondence, we'll use arrows. Okay, and it's actually true, maybe in this case, that the angles are congruent, but we're just going to say that A has a correspondence with D. So we're just going to say like A kind of maps to D. And B has a correspondence with E, and C has a correspondence with F. So if I ask you to write a correspondence or show me the correspondence, you can use arrows. If I ask you to write all the congruent parts, use a congruent symbol. All right, so here's an example where it says, give an example of two triangles and a correspondence between them such that A, all three corresponding angles are congruent, but B, corresponding sides are not congruent. So we're just drawing a picture of two triangles where there's a correspondence between congruent angles, but not corresponding sides. The corresponding sides are not congruent. Okay, well, this is simply the idea of kind of what the example is on the other page. We can have two triangles, ABC, and we can have another triangle where the angles are the same. Right? A and D have the same angle, B and E have the same angle, and C and F have congruent angles. But these two shapes aren't congruent. And so we just know that A corresponds with D, B corresponds with E, and C corresponds with F. All right, so on this you do question, I'll read it and maybe kind of explain a little bit, but you'll do this one. Give an example of two triangles and a correspondence between their vertices, this is the correspondence, such that A, one angle in the first is congruent to a corresponding angle in the second, so that has to be true. B, two sides of the first are congruent to the corresponding sides of the second. But C, the triangles themselves are not congruent. So basically draw two triangles to scale as much as possible, where you have an angle and two sides in one, and an angle and two sides in the other that are congruent, but they're not congruent triangles. All right, it might take a minute just to kind of draw variations to make something where that is true. But again, do your best to draw it to scale. All right, so next, CPCTC. We did this in class as well, and it's just a phrase that we can use when you're asked, why are parts of congruent triangles congruent? Well, because of CPCTC, basically by the definition of congruence. If two triangles are congruent, then their corresponding sides and angles are congruent. But instead of phrasing it like that, we can just use the phrase CPCTC, which means corresponding parts of congruent triangles are congruent. All right, so an example, I mean, it's just basic, but just an idea. Triangle Hey is congruent to triangle Man. What other parts of the triangle are congruent because of CPCTC? Well, we're given 3 out of the 6, right? There's 3 angles, 3 sides. So we're given 2 angles and a side. Well, if these 2 triangles are congruent, then all their corresponding parts must also be congruent. So we know that angle H has to be congruent to angle M. All right, so that takes care of that third angle. Side HY has to be congruent to, well, let's make sure HYMN. And side EY is congruent to side AN. All right, so these are just the remaining parts that must be congruent because the triangles themselves are congruent. All right, another example, just this time with some numbers. Given that the triangles are congruent, fill in this missing information. We'll do this one, you do the one below. What I usually like to do is just label my picture before I start trying to fill in the answer. Like just label everything I know. And I know A and T have the same measure, right? That's based on this. So A is 70, T is 70. B and D have the same measure. And then C and J. Well, J is 50. So C is 50. 70 and 50 make 120. They all have to add up to 180, so that means B has to be 60 and D has to be 60. All right, AC. AC corresponds with TJ. All right, so TJ must also be 4.7 centimeters. AB corresponds with TD. So this one has to be 4.2. All right, so now we can just fill it all in. Measure of angle C, 50 degrees. The length of TJ, 4.7 centimeters. Measure of angle B, 60 degrees. And the length of AB is 4.2 centimeters. All right, take a minute to fill this one out. And I'm just going to quickly explain the next 2 problems. You're going to do this one. You're going to do this one, which is like what we did in class, where you write what kind of transformations took place, what rigid motions, write a rule, write the correspondence of sides, the correspondence of angles, and then a congruent statement. And then this last problem is just a connection to algebra, same or similar type of problem, but just using equations. Okay, so you're going to do these last 3 problems on your own. Those need to be done. These notes are considered your homework, so you do these. Don't wait to come to class to do them. All right, that's it.